Hello and welcome back to another episode of Effective JaRu, the series where we have a look at effective Java, the book, and try to port each item to idiomatic Rust if possible. So item 17 says, design and document for inheritance or else prohibit it. So the example given here is basically a broken one because the superclass does something that shouldn't be done. It calls an overridable method in its constructor, which basically means that possibly the subclass here is not yet initialized, which in this case leads to, let's run this guy, leads to null being printed first instead of the date, because the date is set in this subclass's constructor. So this print one here will see the right date too late. It's a general thing, which of course has no representation in Rust because there is no inheritance per se. You only implement traits. Thus, the entire class of problems isn't available in Rust, which is a good thing, I think. So basically, the problem here is self-use, right? So if you, or generally speaking, if you implement a class that is just a concrete class without the intent to being overridden, then make it final. Make it final right away, like here. I think that's the idea. Or if you want to have package internal subclassing available, then you can also make all the constructors private and just have static creator methods here on the type itself, which will still allow instantiation, but obviously will prohibit subclassing because of the private constructors, which you can still use if it's package private, right? And yeah, that's basically it. I think we can go through here, and yeah, what he suggests is that any kind of self-calling of the superclass is supposed to be documented, which of course is a very soft contract in the sense that it's just in the documentation, which also needs to be maintained. And there's plenty of, it's very error-prone, I say. It's very difficult to do that right. And there's no standard for this, so yeah, it's kind of non-obvious how all this behaves, and probably you have to study the implementation itself in order to be sure that you're doing it right after all. And then you have no guarantee that this will keep working. And yeah, why is all that so difficult? Because inheritance violates encapsulation. In a way, the idea of inheritance in the way it's implemented here at least is flawed because you can't protect yourself of certain things. Of course, the compiler would theoretically be able to check that and prohibit things. I mean, it's no rocket science here. This is in the code, so the compiler knows about it, but the Java compiler doesn't know about it. So if inheritance ever happens to come to Rust, I seriously hope that the compiler will prevent all these kinds of issues from the get-go and force you to do it right. Yeah, it's basically suggested that you, in order to test this correctly, to test your subclass ability correctly, that you write at least 2 subclasses yourself, just to be sure that you get the right amount of protected fields that are accessible by subtypes. And ideally, you have another author as well that writes at least one of these subclasses. I mean, it's an arbitrary number, 3 subclasses. Maybe you need more, maybe less, but generally you have to, that's part of the testing. In the moment you want to have something that is subclassable. Quite interesting, which is why I have once again highlighted this, is that if you want to be subclassable properly, you have to know about the clonable and serializable interface and implement something in a protected fashion so that things have a chance to work. And that's really, really interesting. And really important to not forget, obviously. And I think it's easily forgotten. Yeah, all in all, subclassing or inheritance or whatever, it's the same kind of, right? It's difficult to get right. I think if you're just implementing the subclass, then it's easier than designing a good superclass. Yet I would probably attempt to use composition most of the time and not to subclass anything unless it's supposed to be made that way, right? And basically, if you have a class that you haven't tested for subclassing, then make it final. And then in any case, basically limit the use to the desired use as far as possible. At least here, Java will help us with the final keyword. And that's kind of a good thing. Also mentioned as kind of a trick to prevent self-calling of overridable methods, right? Which can change the behavior that subclasses expect. Basically to isolate, to make sure that one overridable method does not affect other overridable methods in any way, so that they're kind of singular units, is to put shared code into private methods that your overridable methods will call. So in the moment you do indeed want to share stuff, you would call your private implementation so that there is no self-call going on. And this makes total sense. This is also a problem in basically any language. Right? I've seen issues like this in Python. I've seen issues like this in C++. And the only thing you can do here is to document it and to prevent self-calling. But if you keep that in mind, I think you will be relatively, kind to those who want to subclass your superclass. Still, it's a complex concept, and it's difficult to get right and to write code that can remain stable for a long time while being able to adapt by changing implementation details that are not exposed to the public. Yeah, I think that is that short episode, but couldn't write anything in the Rust realm there. Thanks for watching and have a good day.